Chapter 4.5, Day 2, Solving Polynomial Equations. Example number 3. The rational root theorem. If fx equals an x to the power n plus an minus 1 x to the power n minus 1 plus so on a1 x to the power 1 plus a0 has integer coefficients, then every rational solution of fx equals 0 has the following form. So the form is p divided by q, which means factor of constant divided by factor of leading coefficients, and in this case that would be a naught divided by an, which means that is going to be the last number and the first number. So you're going to find the factor of the last number divided by the factors of the front number to find the possible rational solutions of the polynomial. Now we are going to do the example related to that theorem we just did. We're going to find all the real solution of x cubed minus 8x squared plus 11x plus 20 equal to 0. Step number 1, determine if you are able to factor this polynomial equation. So it means that if you can take out the common factor or do the grouping. In this case, we cannot factor this, so we just have to say no. We cannot factor it by grouping or by taking the common monomial. Step number 2 is if you're not able to factor, list all possible solutions using rational root theorem. So you're going to have to find the leading coefficient for that and the constant. Leading coefficient for this equation is 1 and the constant term is 20. Now we are going to find out the factors for the last number divided by the factor of the front number. So the last number is 20 and the front number is 1. Factors of 20 are plus or minus 1, so you need to take the integers. So integer means you're going to take positive number as well as negative number. Plus or minus 2, plus or minus 4, next is plus or minus 5, and plus or minus 10, plus or minus 20. So these are the possible factors that can divide this polynomial completely. So we don't know which one is going to be the factor though. We always start from the lowest one, or we always start from the lowest number that we just found. We're going to test which one is going to be our actually factor. So to do that, we are going to use synthetic division, and we're going to identify a solution that results in a remainder 0. Just remember that in order to be a factor, we should have a remainder 0. So just taking example of the same type, remember the same simple equation we used to do. So if 4 divides 12 completely, it means that 4 is going to be a factor of 12. Similarly, if any number that we just have here can divide the polynomial completely, means remainder is 0, then that number with x will be its factor. So we are going to always start from the lowest number. So the lowest number is going to be 1 or negative 1. So going to start with number 1 and divide this polynomial. Here we are going to write the coefficients of polynomial. So it's going to be 1, negative 8, 11, and 20. So that's going to be 1, negative 8, 11, and 20. And we are going to divide it with 1. So bring down the 1 as it is. and multiply it by this one, so 1 times 1, and write it over here. So just like synthetic division. And then we are going to add -8 and 1. That's going to give us -7. -7 times 1 is -7. 11 minus 7 is 4. And here we got 4 plus 20, so that's going to be 24. So this doesn't work because this does not give us a remainder 0. So it means that x minus 1 is not a factor. You're going to write this in a factor form, so it's always the opposite sign. If it's positive 1, then we're going to say that x minus 1 is not a factor. If it's a plus 1, then use a negative sign. If it's negative sign, then use a positive when you make a factor. Now we are going to try if -1 can be a factor. So if we get 0, then we can say that is a factor. If we don't get 0, then it's not a factor. Bring down 1 as it is, multiply it with -1, you get -1. -8 and -1 is -9. -9 times -9, 1 is +9. And then you're going to add, you get 20. 20 times -1 is -20. And when you add that, that's going to be 0. Now this time the remainder came out 0. So the formula that I just discussed in the previous examples, that in this case if the remainder is 0, then dividend equals to quotient times divisor. Now in this case the quotient is this one starting from x squared, so that's going to be x squared minus 9x plus 20, so that's going to be a quotient. So the quotient is x squared minus 9x plus 20, and then the divisor is this number. If you want to write this divisor into a factor form, then we are going to write it x plus 1. So that's going to be x plus 1. So this is a number, but its factor form would be x plus 1. And this one start with the x squared and then x and constant, and we'll make a quotient for the dividend. So we got the two factors right here. We got the factors that are x plus 1 times x squared minus 9x plus 20. So again, what we did here, we had this cubic polynomial. We broke this cubic polynomial into two factors, that is x plus 1 times x squared minus 9x plus 20. And this is really going to help us to find the factors of this one, because we can apply the factor cross method to find the factor of this one. So now we are going to use the cross method for that. So that is, on the top number we have 20 and on the bottom -9. We're looking for two numbers that give us the multiplication as 20 and add as -9. So that number should be -4 and -5. We write the factor x plus 1 as is, and the other factors are going to be x minus 4 times x minus 5. Now this big polynomial that you see in this given equation is broken into 3 different factors, and these are the factors of this polynomial. And we are going to now find the x values. So we're going to set all of these factors equal to 0 one by one and find out the x-intercept, or in other words, x values or zeros. So we got x equals -1, x equals 4, and x equals 5. we can graph this, although it's not asking us to graph. If you want to graph it, you have to decide what is the shape of the graph. So this is a third degree equation. So shape of the graph is going to be a S shape, cutting at -1, 4, and 5. The leading coefficient, that is +1, is going to fall on the left and rise on the right. So here is going to fall and is going to cross 4 and is going to again rise on the right side. So just the overview of this example, what we did, we first used the rational root theorem to find out what are the possible numbers or factors that can bring this equation down to quadratic equation by having the remainder 0. So we tried with the 1 and then we tried with the -1. If this doesn't work and do not have a remainder 0 or do not give us remainder 0, you can try 2 and -2. If that doesn't give us remainder 0, then you can try the next numbers. But whenever you get remainder 0, stop right there, and this number with opposite sign will make a 1 factor, and this quotient will make another factor. Once you get to the quadratic equation, it's really easy to make factors for quadratic equation by using cross method, or you can also solve it by quadratic formula. So it's really easy to find the x values one is brings down to quadratic. So that's why our aim is to divide this and get the remainder 0 to bring it down to 2 smaller factors so that we can solve for x values.